Hello, my name is Simon Thomas. I'm the product manager for Teledyne LeCroy's Protocol Solution Group Storage and Networking Protocol Analysis Tools. And today we're going to talk about some fundamental requirements for hardware-based protocol analyzers and air injectors for fiber channel over Ethernet, iSCSI, and other 10 gig and 40 gig related Ethernet protocols. Today we'll start off by looking at some of the setup requirements and demonstrate how to establish efficient triggering, memory control, and filtering for these applications. So the first thing we'll look at is the port configuration window. I'll select a new project here from the File menu. And what we're trying to show here is that we have several analyzers, some online, some offline. And I'm going to select the SierraNET M408 and adjust the port configuration. In the current port configuration window, you'll see that there's several options to choose from for 10 gig, 40 gig, and also fiber channel. We're going to select the analyzer jammer analyzer port configuration on the bottom left hand of the screen. The red circles denote analyzers throughout this presentation. The green triangles denote jammer throughout this presentation. And in this case, we're capturing traffic with the analyzers before and after any jammer events are applied. This way we can verify the traffic before it was impaired by our test script and verify the impairment and the error recovery after the test is completed. So I'll select this 10 gig E analyzer jammer analyzer and push OK. Push OK one more time. And we open up a project window at the top of the Net Protocol Suite software. The analyzer is active because it has a green background. Next to this, we have a couple items with small wrenches. These are typically trigger and filtering menus, and we'll go into more detail on these in a moment. We also have some triggering and filtering selections for either snapshot or a more precise event trigger. We have a project window where we can store our library. We have a start recording, stop recording, and a port status on the right hand side of the project window. Below that we have the jammer configuration portion of the project, the jammer library where we can create new libraries and new scenarios or select previously created ones, and a start jam and stop jam window. So some of the important things I'd like to point out today include the amount of memory available for a trace capture. In this particular analyzer, I have over 32 gigabytes of capture buffer for my trace analysis. We will go ahead and select something a little smaller for today's purposes of 256 megabytes. Next to the segment size, I have a recording settings button. This allows me to determine where I want to save the trace. Given the size of trace buffers that are available in the SierraNET M408, we also support network directories, so those traces can be saved into a remote location with larger storage available. And we also have the number of segments, and this allows you to separate a very large trace into multiple files for the purpose of easier review or storage or sending to a colleague or customer at a later time in a smaller file size. So we'll leave this right now on my local machine. I'll maintain a number of segments as 1, and in the protocol error detection, this denotes all of the error categories that we will look for using the hardware state machines in the SierraNET. I'll press OK from there. Next, we have two modes. We have a snapshot and we have an event trigger. Snapshot is quite simple in the sense that you set your buffer size or segment size of 256 megabytes in this example start recording. It will fill the 256 megabyte buffer. It will automatically stop recording and present the trace to you in the bottom portion of the screen as you see below. The event trigger is one of the most important functions of a protocol analyzer tool, and this allows you to trigger the analyzer based on a specific criteria that you specify as a user. I will select the trigger position slider now. Typical use of this slider is if you're looking for error recovery and validating different forms of error recovery, you would slide the slider further to the left, and more of the 256 megabyte buffer, in this case 80% of it, will be preserved after the trigger, and only 20% of the traffic in the buffer before the trigger will be preserved, and then the analyzer will stop recording. In the trigger and filter settings window, we have a couple modes here. We're going to switch to the advanced mode. It's quite simple to use. We have a nice library on the left hand side with user patterns. These are user libraries that the user can create, save, and use again at a later date, or provide to another analyzer user and they can use the same libraries as well. I also have an FCoE category in here with some pre-existing patterns that I've already built earlier. And then the preset menus will always retain their original formats but can be modified, and we'll go into that next. The important thing to recognize in a protocol analyzer is the ability of the state machine to be very specific to the user and your requirements for a precise triggering and filtering mechanism. The SierraNET has the most robust triggering mechanism in the market. We can support up to 24 states. We have 4 transitions per state, and we can roll back or advance to any state within the 24 state window. In this case, I have 4 states on the screen. All of them are ORed together because I'm not transitioning from one to the next, and currently they don't have any events in them. So we'll go ahead and fill in some of those now. Delete a couple of these existing states that I put in as an example. And we're going to look at the FCoE window or category in the GigE sequencer. I'll open up BASIC. BASIC is important in the sense that it has some very common error recovery mechanisms under basic link service. So if I move that over into state 0, you'll see that I'm triggering on any basic link service. The entire basic link service is framed. We fill in the ether type as FCoE. Everything else is relatively generic to any type of basic link service. We'll go ahead and we'll select the R control in the frame header. Double click this. Scroll down to number 81 for the ABTS. And this is going to be our trigger in this case. Down at the bottom, you'll notice that there's a counter of trigger on the first occurrence on each link or any given link. I could also filter out specific ports or entire links on the left-hand side at the bottom here. And I'm going to maintain the selection of trigger on given pattern with variable header length where my mouse is pointed to now. This selection, though not necessarily applicable for ABTS, is a very powerful mechanism that will allow you to apply a trigger regardless of variable header lengths. For example, if there's a VLAN field or not a VLAN field, this mechanism allows you to trigger on that frame regardless. If I uncheck it, then it would trigger on the specific frame structure provided in the window above. So we'll maintain that as checked. So this is currently at state 0 with an FCoE basic link service ABTS. I have the ability here now to trigger by selecting this button for trigger mechanism. I have timers, so I can set a timer with this trigger as well. For instance, trigger on this ABTS or trigger X seconds or milliseconds or microseconds or D words after this ABTS and start the trigger and stop recording. Or my last choice is that I can jump to a new state, and in this case I select that mechanism and I create an if-then condition where I can fill in another field here, and it will the trigger mechanism will need to be satisfied in both states before it is applied in the last state. I'm going to delete that. It's not necessary for today's demonstration, but it is an important item to have in your system if you need it. We'll switch back to the easy mode. We'll select the same basic link service trigger. We will go down to the R control again under frame header. Double click this. Select R control of 81, which again is an ABTS. We'll trigger on the first ABTS on any port. Push OK. And then we'll go to our filters. The filters are important if you want to manage your memory buffer in particular. We can filter out payload if you're not interested in analyzing payload. The recommendation here would be to filter up to 100 bytes of the payload so you can preserve any SCSI level or other information at the beginning of an FCoE payload. Idles if you're not concerned about your link level, and auto negotiation if you're only interested in analyzing or capturing traces after the link has been negotiated. We'll turn off the filters in all instances except for the payload, in which case we'll preserve 100 bytes of that payload. And we'll push close. Now that we've established our triggers and filters, we'll go to our jam scenario. Here you can see my jammer is on ports 1 and 2. My analyzer is on ports 1, 2, 3, and 4. What this means is I'm going to analyze, then jam, and then analyze in this session.